We present InfoGCN, Representation Learning Framework for Human Skeleton-Based Action Recognition. Human action recognition is a fundamental problem in computer vision with rich applications, including emergency detection, sign language recognition, and gesture recognition for VR and AR. In particular, human action recognition based on the skeleton, which recognizes action from a sequence of skeletons, has attracted much interest in computer vision because of its robustness against a cluttered background. Although several studies have focused on encoding a skeleton, less attention has been paid to embedding this information into the latent representations of human action. To tackle such challenges, we introduce a new learning framework for skeleton-based action recognition. Our approach advances the state-of-the-art in three critical aspects. The first is the algorithm for representation learning. We propose an information bottleneck-based learning objective and a corresponding loss to guide our model to learn maximally informative representations for skeleton-based action recognition. The second is the encoding method of the skeleton. The proposed encoder infers an intrinsic topology of joints, which provides contextual information beyond physical connectivity. Lastly, we propose a multi-modal skeleton representation by utilizing joints' relative positions. It provides complementary spatial information of a joint. Now we'll discuss the detail of our method. We design our learning objective to learn a latent variable containing compressed information with respect to the input sequence of skeletons, while preserving maximum information for the target variable, which represents an action label. We derive our loss function from a proposed learning objective like following. Second, we design a novel neural module called self-attention-based graph convolution. Graph convolution-based approaches show promising performance in the task. However, graph representation of the skeleton using bone connectivity, which we call extrinsic topology, has an inherent limitation. It can ignore possible joint relations, which we call intrinsic topology. The intrinsic topology of joints provides contextual information to recognize human action. In this context, we develop a novel self-attention-based graph convolution module named SAGC to extract the intrinsic joint relation. Considering all possible relations, SAGC infers the strength of the joint relation using self-attention. Lastly, we introduce a multi-modal representation of the skeleton. Previous work shows that the ensemble of models trained with bone and joint information drastically improves action recognition performance, implying that these different representations of the skeleton are complementary. Based on the fact that bone information is a linear transformation of a joint, we design additional skeleton representations by generalizing the relation of joint and bone. By coupling aforementioned three proposers, we introduce a new learning framework for skeleton-based action recognition, named InfoGCN. It takes a sequence of skeleton as an input and successfully recognizes action. To demonstrate the advantages of InfoGCN, we conduct skeleton-based action recognition on three large-scale datasets. We compare our results with previous state-of-the-art methods. InfoGCN surpasses the state-of-the-art methods on all three datasets. To validate the effect of the proposed objective, we trained our model with and without MMD loss and compared action representations by principal component analysis. Latent representation learned with MMD loss presents a denser and non-overlapped class conditional distribution that seems more discriminative than those without MMD loss. Here we illustrate examples of the skeleton and its corresponding topology inferred by InfoGCN to observe the patterns of how a joint attends to each other. Colored lines indicate inferred topology from a selected joint to all other joints. The thickness of the colored lines on the joint is proportionate to the strength of the inferred relation. We observed that similar poses could have different intrinsic topologies depending on their behavioral context, which is why our model distinguishes behavior pattern better. We present an information bottleneck-based representation learning framework, InfoGCN, for skeleton-based human action recognition. Notably, our framework achieves state-of-the-art performance on skeleton-based action recognition. Thank you.